try and reflect your methodology in your research aims and objectives. What I mean is just try and say that I'm trying to check, I want to assess the impact of variable A on variable B. You don't have to say I'm going to conduct EFA or independent sample t test. No, you just give us a broad idea. Okay, so don't be very specific. You just say I want to assess or I want to explore the relationships between such and such a variable. So something like that. Okay, don't get too specific to mention the methodology. So when I know you're trying to look into, say, the objective of assessing the impact of risk reduction strategies on project success, I know you will be conducting some form of a linear regression. Okay, so keep it very broad, but just some idea for the reader as to what they should expect in terms of analysis. Okay. So is EFA reliability analysis clear, guys? Any questions? Okay. This is I told you this is the analysis. In reliability analysis, these are the two most important tables that you will need to include in your analysis. Now, multiple regression. Again, multiple regression is the estimation of linear relationship between the dependent variable and independent variables. As I said, dependent variable is the one which gets influenced by other variables, and independent one is the one which influences. It does not get influenced. Okay, now if I want to explore how much an individual, a job satisfaction of an individual, if I want to see how much he enjoys his job, then maybe I will go and collect data or information on variables such as his salary, his working relationship, with other colleagues, his academic qualifications, or his age, his age, and so on. So I will collect information on all these variables and see the impact of this on his enjoyment with the job. Okay, so based on that, I'm able to accurately predict job satisfaction or how much a person enjoys his job based on the scores he gives to other aspects like the age or academic qualifications, his maybe the working environment, so on and so forth. So there can be so many variables. Okay, so you can, once you get those scores on those aspects, you can predict something accurately on the dependent variable. Again, there are a number of applications with multiple regression. So once you perform your multiple regression, there is an equation that you are expected to include in your write-up. Don't ignore that particular aspect. Okay? And what is that equation? So the equation here is y is the outcome variable. That is the dependent variable. Okay, that is equals to b naught is one constant that you get when you perform the analysis, and it is b1 is the coefficient of first predictor. The coefficient is there is certain percentage of variable 1, certain percentage of variable 2. Maybe how much a person enjoys his job is b naught, some constant, but plus 0.5. 50% is you can explain through his age. Maybe 0.1 is based on his qualification, or maybe there will be 0.7 which is based on his working hours, or maybe again 0.3 based on working relationships. So if we get those values, we can see how much that each independent variable will contribute to that overall outcome. Okay. Like say another example that you can take is the relationship between age, the time with company, and compensation. Say you want to predict how, why a person gets how much, why he gets so much compensation can be explained by his age and the time he's based in that company. So you can explain compensation based on those two variables, that is his age and the time he's working for that company. The longer you work for the company, maybe your compensation will be more, or the older you are, the compensation is more, something like that. Okay, so as a result of this particular regression analysis, what we can do is we can make much more accurate predictions. This is because about the dependent variable. So you can have a number of variables. It's not restricted to one or two. But then again, you have to make sure that the relationship between the two is linear. Okay, it follows a straight line. Now this is the same example. We've got compensation based on the results once you perform the analysis. Then you can say 27% of why a person earns what they do is related to their age. So you're making accurate prediction. Or we can say 10% of why a person earns what they do is related to their time in the company. Okay, then you can introduce other variables as well. Their performance appraisal reports, how they performed, okay, their qualifications. You can introduce as many variables as possible, and you can make predictions about the compensation that they get. Okay. When you go to SPSS, you will have a data set, like how we've done previously. You enter all the data that you want. Then you go to analyze, you go to regression, and select the linear option. Okay. When you go to that particular linear option, this particular window comes up. Okay. In this window, you have got two separate boxes. One is for dependent variable and one is for the independent variable. So select the dependent variable which you want to include, and then you introduce all the independent variables in this box. Okay, and the regression, there is a particular option which is called as the method, how the variables are entered into this regression model. Okay, we will go for this stepwise option. Okay, in stepwise option, what happens is each independent variable is introduced one after the other. Okay, you introduce the first variable, check its influence on compensation, the second, so on and so forth. Okay, there is another option called as enter, where all the variables are put in one go. Okay, the most sophisticated one is stepwise, so try and go by that one. And then you have to select the statistics option. In that you select estimates, you select model fit. Model fit is a very important table that you need to have. You go for R-square change, descriptives again, and you go for collinearity diagnostics. And then you select this option for Durbin-Watson. When you select this option for Durbin-Watson, what you're trying to say is that, see, sometimes what happens is there is some difference between what is observed and what is predicted. Okay, so we will be assuming certain error terms. Okay, in this when you're doing the analysis. When your Durbin-Watson is around the range of 2, it means that the error terms that you have estimated is you can defend them. They're almost right. Okay, but if you get something in the range of say 5 or 6 or 7 and all that, it says that the error terms that you have assumed are not right. So it has to be around the value of 2. Anything little bit less than 2 or little bit over 2 is fine. Okay. And then you go to the last option. You don't have to do anything with plots or save. Okay, just leave it. And then you go to the options. Okay, here you select. This is default option, like you use probability of f. And then include constant in the equation. Okay, so you select that option, that is just to include your B0 in the equation that you want to write at the end of your analysis. So that is for B0. And then you exclude cases list-wise. So any questionnaire with a missing value will be excluded. Okay, multiple regression more than EFA is very sensitive. Okay, if the people have not answered questions properly, or if there are too many missing values, then multiple regression may not produce those the results that we want. EFA is quite robust in that way. Even in multiple regression, sometimes we have this option called as multicollinearity. That if there are two dependent variables which are closely related, okay, and they're kind of confusing. If they're measuring somewhat the same thing, and you introduce that in your analysis, then you may not get the results you want. Okay, but EFA is not like that. It's not very sensitive. Multiple regression is quite sensitive. And then you get all these tables when you do your regression. The first table that you get would be your descriptive statistics. Again, it just gives you what is the mean value for each particular variable. standard deviation, and n is the number of questionnaires that you have got. Okay, if you are only doing multiple regression, then you can talk about these results. Then we have got step, because we have used this stepwise method. You will get one more table which is called variables entered or removed. You don't have to include it. I've just specifically included it in this slide just to show you that this is how variables are entered in stepwise. Okay, if we use the enter method, we may get a different table altogether. And then the most important table in your multiple regression analysis will be this model summary. Okay, always make sure that you include it in your write-up. Okay, this is what your write-up will be based on. So what happens is, in this particular table, what I get is I get model 1, model 2, and model 3. Okay, so what now if you just see the R value, which is again the correlation, and R square. For the A option that we have given is contingency planning to deal with unforeseen risk. So what this particular analysis has done is it's first put the variable 1, that is contingency planning, and check how much amount of variance can this model explain. So when I put one variable, it is able to explain 0.22% that influences the dependent variable. Okay, then I have got model 2, where we have got 2 contingency planning and the second variable has been introduced. So those two variables together are explaining 0.31, that is 31.2% variance in the dependent variable. And then I have got the third model. Okay, in this model, what is happening is it is explaining 30.359, that is 35.9% variance in the dependent variable. Okay, so because we use the stepwise, it is just putting one variable at a time, which is actually explaining the outcome variable. Okay, in this particular option, what we had is we had the risk reduction strategies, and in the questionnaire we also had one overall question that how risk reduction strategy can impact project success, the influence of these risk reduction strategies on project success. So what the model is trying to tell me is that these three strategies, okay, are able to explain 35.9% of project success. That project success is related to these three particular variables. You can explain project success by these three variables. Okay. See, what happens is R is the correlation, and this is R square. It is just the square of that number. But we have got adjusted R square. That is what you need to include in your model. Because what happens is R square produces an overinflated R value. Okay? Adjusted R square is taken because it takes into account the number of variables that you have put into the model and the number of questionnaires that you have got. So it produces a very realistic value, okay, about variance, about your dependent variable. Okay, so always go for the adjusted R square. It tells you realistically how much these strategies influence project success. Okay, and when you're writing up, make sure that you don't ignore this particular aspect. Okay. Okay, and then another aspect about this regression would be your ANOVA table. It is the analysis of variance. Okay, in analysis of variance, because if you see the previous one, we have gone for model 3 because we've got 3 particular variables which are explaining project success. Okay, so we can in model 1 it is only one variable explaining. In model 2 we've got 2 variables. In model 3 we've got 3 variables and they're explaining a lot of variance in the project success. So we'll go for model 3, right? So if you go for the next table, if you see the ANOVA table, we will be checking model 3 because we want the one which can explain a lot of variance. Yeah, and here we see the F value which is 10.158, and we have this value which is 0.00. So we want to have an F value, that is a variance, which is statistically significant. Okay, if it is not significant, means we are not able to explain anything much. So when you are reporting your multiple regression, you have to include your model summary, your adjusted R square value, you you have to tell me what is your F value and whether it is statistically significant or not. Okay? And then last but not the least, we have got the coefficient tables. Now this table will help us write the equation, okay, that I was talking to you about. Now here we have got our beta values here. This is the constant, which is the B naught. It says it is, I can't read from I'll just read from the screen. We have got, okay, so that is our outcome variable is project success, okay? So project success can be explained by this particular constant, which is 0.1649 plus 0.29 of contingency planning, plus 0.226 of buying out of risk, plus 0.184 of continual implementation, plus an error term, which we can define because our Durbin-Watson is around the value of 2. Now, when I do my, this is how I would report my multiple regression results. So I would say you have to begin by citing, you would report the significance of the model by citing the F value. I told you in NOR table, what is the F value? What is the associated P value? P value is the significance value along with adjusted R square, okay, which indicates the strength of the model. So in this case, my adjusted R square was 35.9% variance. F is 10 at P less than 0.05 using the stepwise method. So this is my outcome variable. So I can explain project success by this constant 0.29 of V7, 0.226 of V6, plus 0.184 of V8 plus an error term. So we are saying we can predict project success knowing these three variables, and this is the proportion they contribute. So V7 contributes more than, we've got V6, and then we have got V8. So we've introduced a number of independent variables, but the SPSS has picked up the ones which actually relate to project success. Okay, so it's just 3 out of, maybe we introduced 8 or 9, and it's only picked up 3 which are statistically significant, and we have got a good model. So maybe there are other aspects that explain project success. So, but at least we are able to explain 35.9, around 36% of what contributes to project success in terms of risk reduction strategies. Yes, guys? Make sense? Okay, and that's it. I'll just do the analysis. So if you go to your okay. Now in the CPM folder, I have put another file which is called MR sample, which is for multiple regression. If you open that, has everybody got access to Teams Online? Because I know some people haven't. Have you got, guys? Yeah? Okay. So open this particular file which is called MR sample data. Okay. The file has already been set up, so you don't have to do anything much. Okay. Here I have got all the risk reduction strategies, and I have got this dependent variable, which is the impact of risk reduction strategies on overall project success. Okay. So this is my dependent variable. So I have named it as D1, and the rest independent variables, 3 to 12. Okay. And I don't have any missing values, so I have not reported them. And then in values, again, I would go and write those what the scale that I have used. Okay, copy it over. The same thing that we did for exploratory factor analysis. Okay. So what I would do is I would go to analyze, and then I would go to regression. Okay, and in regression I would select linear, the second option. Okay, and then first is I would introduce top one, hold the shift key and select the last one. Okay, and then move these variables into the independent box. Right? Okay, guys. And then, as I told you, the option that we are going to select would be stepwise regression, where we put each variable in a sequence. Okay? Is everybody okay? Yeah? Okay, and then that's it for this particular option. We go to statistics, we go to estimates, we go for R-squared change, we go for descriptives, I don't think we go for partial correlation, collinearity. Yeah, sorry, you ignore partial collinearity. Only descriptives. The model fit, R-squared change, descriptives, and collinearity diagnostics, and you go for the Durbin-Watson. Continue. Options. Just leave it the way it is. Okay, leave it as the default option, and select continue. And that's it. Your analysis is almost done. This is all that you have to select, and then just select the OK button, and you will have this output. The first one is the descriptives, just giving you mean, standard deviation, and you have got the correlation analysis, which you can report, but it's up to you. But it's not that important. Sometimes what happens is when the independent variables are very, very closely related with one another, the Pearson correlation value that you get will be very high, which means they are both measuring the same thing. And if you have two independent variables which are very closely related, then they have a impact on the dependent variable. You can't predict which one predicts more. So only in that case you would go and check. This particular table tells you about the variables that were entered, and this is specific to stepwise regression that you would get. The most important table is your model summary. Here it tells me model 1 has got R value of 0.48, and it is only when you check that A is the predictor variable, is only contingency planning, that is V7. Model 2, it has two variables, V7 and V6. We've got model 3, which is 7, 6 and 8, and it is explaining 35.9% variance in project success. So I will go for the third model, which has got an adjusted R-square, okay, which has got a Durbin-Watson of 1.967, which means I can defend my error term. I will go for the ANOVA table, and because I'm selecting the third model, I will see what is the X value, what is the significance, okay, and then I will proceed to coefficients, where I will take down the constant for writing the equation, and tell which how much each variable is contributing, and you write the equation based on these particular unstandardized coefficients, unstandardized beta coefficients. The SPSS will produce a table which will tell you which variables were excluded from your analysis, because not all the variables that you enter are in the model. There are some which have been excluded. So it will also tell you which have been excluded. And that's it. That's your multiple regression. So always remember, also when you're copying the tables over, right, for the model summary, please include the ones which are here. A is what is the predictor variable. Just don't include the table on the top. You include all the data that is with the table, because I wouldn't understand which is the dependent variable and which is the independent variable, and I don't even know how many variables are contributing towards explaining the model. So whatever is written below the table, also include that. Okay, that particular table is incomplete on its own, so copy the whole thing over. Okay. So I have told you in this particular slide how to report multiple regression. Okay, and when you're writing about it in your discussion, please include all these aspects. That's it. We also looked at the impact of risk reduction strategies on project success, and these three emerged at the forefront, and they were contributing so much, in so much proportion or variation, and you also have to explain why V7 was contributing more compared to V8, and why there were some independent variables, why they were deemed to be unimportant and they were taken away. Okay. And last option that we have got is independent sample t-test. Okay. Why do we do an independent sample t-test? One is like if you want to compare the differences in mean between two separate groups. Like say we've got a sample set of men and women working for a university, and we want to see who is more culturally intelligent, whether men are culturally intelligent or women, something like that. So if you want to make comparison between groups based on the mean scores that they would give for a dependent variable, then you can use sample t-test. Okay. So this form of analysis answers the research questions by comparing the mean scores, the mean values that they would give on a particular dependent variable for two different groups. So this particular analysis is quite restricted because you can only make comparison between two different groups. Okay, there are other options like Kruskal-Wallis where you can compare 4 groups or 5 groups, but this one is only for 2 groups. Okay. Now say I have got a research hypothesis. Do those with experience in sustainable projects believe that the concept of sustainability is more important than those without experience? Okay, so I want to see whether there is a difference in opinion or on the mean score that they give. So I have taken 2 groups. One would be people who have worked on sustainable projects and people who have not worked on it. So I want to see what is their perception. Okay, so in that case I can use this particular t-test. Okay. How do we do the t-test? Again, the data is set up the same way as we did for EFA and multiple regression. You go to analyze, you go to compare means, because here you're comparing the means for those 2 groups, and you select independent sample t-test. Again, in this particular thing, it's very straightforward and simple. You just move all the items that you want into test variables and the grouping variables. That is, you want to test 2 different groups, whether it is architects, designers, contractors, whatever. Okay, into the second group, and then you've got options where you select the 95% confidence interval. Okay, and then you just define which groups you want to include. Okay, if you we will do that analysis. What you can do is once you do this analysis, once you select these items, you select the grouping variables, then the output that the SPSS produces are 2 tables. Okay, these are very important. The first table will tell you about the means, because we are comparing the mean. It will give you the first one will be the grouping variable. Here I am doing a comparison between contractors and designers. Okay, and there are 3 particular variables I want to check whether their opinions differ or not. And then it also tells you the number of questionnaires that you got from contractors, how many questionnaires you got from designers, and then it gives you the mean value and standard deviation and an error term. Now if you check the first particular option, there is not much of difference between the mean values between designers and contractors. They seem to be in agreement with that particular term. But if you check the second variable, there is a difference. One is 3.6 and one is 4.0 something. So you see there is a difference of 0.4. So the designers are more in agreement compared to the contractors. Even the last particular one, it is 3.9 and that is 3.5. So you see there is a difference in opinion, but we cannot be very sure that yes, they do differ. We want a result that is statistically significant. So when you just look at this particular table, you know that there is a difference in the mean value. But once you go to the next table, that is independent sample test table, okay, so what happens is, okay, we have got the first variable. It produces a Levene's test for equality of variance. Variance and standard deviation are very closely related. Standard deviation is a square root of the variance. Okay, so in Levene's test, what happens is there is a null hypothesis again that there is no difference in variance between the two groups. Okay, now if we get a Levene's test which is statistically significant, it produces a F value which is it will produce a significance value. Here we have got a value of 0.08. So this is less than 0.05. So 0.05. This is 0.008. This is less than 0.05. Yeah. So what happens? It means that we have to reject the null hypothesis of the Levene's test that the variances are equal. So we go and select and see the second option where variances are not equal variances not assumed. Because it is statistically significant, we rejected that hypothesis, which means that the variances are not equal. So we go for the second option. Okay. So when we see the second option, we have to look for the t-value, which is 1.267, the degrees of freedom it has, and see whether it is statistically significant or not. In this case, it is 0.212, which is greater than 0.05. Means that there is no difference in opinion or in the mean value between the designers and the contractors on this particular variable. That is, lack of communication between projecting is the main cause for delay. So what we are trying to do is, this particular research project was done on what causes delay on construction projects, and we were trying to assess the opinions of designers and contractors. So both of them, they don't agree that lack of communication. Though they're given mean values, there is not much of difference in their opinion or the mean value they gave for this variable. Okay. Now we have got a second option. Okay. Late delivery of equipment and materials is the main cause for delay on construction projects. Okay. Now we first go for the Levene's test where we check for the F value. We've got an F value and the significance is 0.447, which is greater than 0.05. So what it means is, because it is not significant, statistically significant, means we cannot reject the null hypothesis for Levene's test, where variances are assumed to be equal. So it means the variances are equal, almost equal. So because variances are equal, then equal variances assumed. You look at this particular row and then look for your p-value, which is 1.976. What is the degree of freedom and what is the significance? Now the significance is 0.051, which is very close to 0.05. So because they are so close and the difference is quite negligible, I can say that yes, there is a difference in opinion or the mean value the designers and the contractors give to this particular variable, where architects are more in favor because the designers gave a mean value which was higher. Okay, if you go back to the previous table, see here, the mean value here is 4.016 and this is 3.6. So the architects seem to agree more on this. Okay, even if you see the scale that they were given on was, I think, agree or disagree or something on those lines. So they seem to be more in agreement with that particular concept. Okay, and so I can say that yes, based on the independent sample t-test which we did between these two groups, architects, the designers feel that this particular variable is the main cause for delay. That is, lack of delivery of equipment and material is the main cause for delay. So yes, there is a difference of opinion. Yeah, and then we've got the last option which says ineffective management by contractors is the main cause for delay. Okay, and if you check the Levene's test, it is statistically not significant. So I will go for equal variances assumed. And if you check this particular row, I have a t-value, I have a degree of freedom, that is 93, and this is 0.031, which is less than 0.05. So yes, the designers feel that ineffective management by the contractor is the main cause for delay. They give a higher mean score compared to the contractors. Of course, designers will, they would want to blame the contractors. The contractors would agree less on this particular concept. So if you want to highlight the difference in perception between two separate groups, then Things Online, I have given one more data set for independent sample t-test data set. Okay, here we have got C1, okay, which is the organization type, where the values what I have done is I put one for contractor and two for designer. Okay, you need to tell the software, how you categorize people. Okay, so for the rest, I have used the Likert scale that they have used to answer. Okay, and only for this particular option, I have given a different code for each group. Okay, and select OK. And this is a nominal scale, so I've just left it that way. And if the data is again same, it's the scale that we have used is strongly agree and strongly disagree. Okay, for the rest, what I would do is first go to analyze. I would go to compare means, and then we go for the third option, which is independent sample t-test. Okay, that is the analysis that we are using. I select that particular option. Now, what I do is I select the three independent variables that I want to analyze. Okay, and I want to move it into the test variables. The questions on which you want to measure their opinions has to go into the test variables. And organization type, which is the grouping variable, you want to group based on the organization type. I select that and I select the second arrow and I move it here. Okay, now you see there's a question mark next to C1. Okay, it is asking me what are those groups. Right? If you just select on that particular, if you select that one here, select that and go to define groups. Okay, in define groups, group 1 is 1, which is the contractor, and group 2 is designers. Okay, you just type in the numeric values. This particular window will not take any alphabetical values. So you have to, based on your the data that you have provided in your variable view, it will pick up that 1 is contractor, 2 is designer.
So 5 groups independent, like all the
No, because this is independent sample to t-test, it will only test 2 groups. It can't do more than 2 groups.
But in your questionnaire, if you get 5 different groups, so how do you pick maybe the first group and the fifth group? Can you do that?
Yeah, you can
pick
give
like
1 and 5.
right,
Right,
okay, yeah.
You can give any numeric value, okay? And then say continue. In options, 95% confidence, exclude cases, analysis by analysis, and you don't have to do anything in Bootstrap, and that's it. You select OK. Now you get 2 tables. One is the descriptive statistics, which tells you about the mean values and standard deviation error terms, and just based on the mean values that that come up on your screen, you can make out whether there is difference of opinion. Anything above 0.4 will highlight that, okay, yes, there is some difference on the mean values. And then you have got your independent sample speed test. When you're reporting, always first talk about your Levene's test, whether it is significant or not, and then how you assume whether variances are equal or they are not equal. Okay, and then go for either of the 2 options. You have to talk about your t-value, degrees of freedom, and say whether your that particular variable was statistically significant or not. If it is not, means there is no difference of opinion. If it is significant, then yeah, there is some difference in the mean value. Okay, guys? Yeah? Make sense? Yeah. That's about it. You can work on the data set, or if you want, I'll be around.
确知你真的想做多一点东西，你可以做这个，或者你就觉得我你可以做这个，我会觉得多一下这样。
Hi guys, how's it going? Is it okay? Easy to follow?
四个还是可以做。
Well, it's always quite time.